Hi, David Paul back again. This is another very interesting boat, one of my favourite kind of Dutch boats. Absolute, breathtakingly clever Dutch genius. I just think the Dutch are absolutely amazing when it comes to boats. Pretty much anything, to be honest. They're an extremely clever bunch. Now, what's good about this thing? This is what is this, first of all? Well, it's what you call a Tjalk. Tjalk, T-J-L-T-A-L-J-K, Tjalk, like pronounce like that, Tjalk. And this is actually, I believe, this is what's called a Zeetjalk. Z meaning sea Tjalk, and so they can go out to sea. Now, what's different about these Dutch boats? Well, what you'll notice first of all is the bow, instead of being sharp like everybody else's boats, the Dutch have got this habit of making buff-ended boats like this, and it just works. So why does that work? Well, what happens is that the water, I believe, instead of going round the boat like we do in everybody else's boats with the sharp pointy ends, it actually just flows under the boat, rather like a surfboard. So what's good about that? Well, what's good about it is this really wide buff bow gives you more internal space. So for the area that it occupies, its length times its breadth, it's actually giving you a lot more internal space. I've done a few sort of hand calculations, back of cigarette type, packet type calculations on these things, and I reckon that you have at least 1/3 more space in these boats compared to a normal boat. Remember that a normal boat is really quite spiky, a modern yacht, for example, and the rationale there is that your modern yacht cuts through the water. Well, in fact, they don't. These things can do it in a different way. I've seen these things on videos sailing out at sea, doing about 11 knots. This thing hasn't got its sails on anymore. It's just under power. But they can do 11 knots, and if you do the calculation for that, there's a calculation. It works out that that's actually true. It's going at its what's called its hull speed. The calculation is 1.34 times the square root of the waterline length of the boat, and that gives you the speed in knots of what it can do. So you do the calculation on these things, you find that they're actually performing at the value that they're supposed to do, and they behave they're incredibly stable, and they perform in a way that the people who designed them could never have even imagined. I've seen a Scutchy, which is it's a Tjalk type boat, which is shallower than this, being towed behind another boat at 22 knots, and that's something that people 100 years ago could never have imagined. Now, what's good about these things is they're relatively shallow draft. Although this is a heavy boat, man, I have no idea what the length to weight ratio of this thing is, but this is on the heavy side. It's going to be a very comfortable kind of boat to be riding around in. So what's different about these is they're quite shallow draft, which is here in the Netherlands you need shallower draft because of the canals are not deep everywhere, and this area is probably really deep in this harbour. So they're shallow draft, and they don't have a keel. Most boats have keels or skegs or anything, not this thing. This thing has what's called a leeboard. So when you're being pushed by the wave, the side by the wind, the side where the wind is not on, the leeward side, you drop the board on that side, and that stops you making sideway progress through the water and means that you can stay on course. So that performs the function of a keel. And this stuff is just so far ahead of its time, because that there leeboard will have what you call a camber. It'll be twisted outwards, so it's actually like a twisted aerofoil in the air, and it's pushing the boat sideways before you even do anything. And that's it. Now, other features that they have, they usually have these unsteered masts. So there's a oh crikey, I missed that. It's not. It does have its sail. It's just had its mast. I missed that bit. It's got its mast lowered. Okay, so what about the mast? Well, you've got low bridges in the Netherlands, so to get under them you've got to be able to drop your mast, and they do that by means of they have a counterweight on the mast itself, and all they do is they just tip it up and up it goes, and that their mast is unsteered. It should be unsteered. So what's good about unsteered mast? Well, an unsteered mast, you don't have rigging getting in the way, and that's basically it, and much stronger. It doesn't, one of the key things, it doesn't produce downward forces through the hull. Now that thing would take a lot of downward force anyway, but like in a modern boat, you can get considerable downward forces. An America's Cup boat, for example, can have a downward force on the mast of about 50 tons. So that's quite a lot, you know. And these things are low stress structures, so obviously this thing's lasted for hundreds of years, and that's it. As I mentioned on a previous video, all curves, so that's very good from the point of view of stresses, and all local stresses that can build up anywhere, and so it results in less corrosion. They were made in these things were made out of a kind of steel which is much lower in carbon. I've looked everywhere. I don't know if you can get this stuff, but very low carbon steel, what we would basically call wrought iron, and consequently they don't rust very much, and they're not that thick. You'd imagine that was really thick, but they're not really very thick at all. And this here boat, I don't know how old it is. I will go to the post and see if I can spot it, but it's at least 100 years. Oh, sorry, 1892. 1892. There's the number on there. I'll just have a quick look at there's the data, if we can get that. So any of you want to read up on that? Get one shot that you can freeze that frame and have a look. Okay. That's about all I can say about that. Massive internal space. Over and out.